at a few problems on calorimetry. Now, look at this problem. How much heat is required to melt 200 grams of zinc, 200 grams of zinc at 25 degrees centigrade, given specific heat of zinc is 0.1, specific heat of zinc is 0.1, that means 0.1 calories per gram per degree centigrade, and melting point is a 422 degrees centigrade. Latent heat of fusion of zinc is 28 calories per gram. So what would happen? First you have zinc at 25 degrees centigrade. You would have to first elevate it to its melting point. Its melting point is 422 degrees centigrade, right? So then, how much heat would be required to raise it to its melting point? Mass, which is 200 grams, right? Mass, which is 200 grams, into specific heat, which is 0.1, into change of temperature, 422 minus 25, these many calories. Mass, grams, this is calories per gram per degree centigrade, and this is degree centigrade. So that will give you calories. 7940 calories would be required as sensible heat to raise it to its melting point. The second one, what is the heat required to then melt it at 422 degrees centigrade? So now once you bring it to its melting point, then there will be no more sensible heat. The heat provided would be latent heat, right? So then, how L is the latent heat of fusion, right? These many calories per gram at 422 degrees centigrade. So then, the latent heat required would be mass into L, which is the latent heat, which makes it 5,600 calories. So what's the total amount of heat to melt zinc? The total amount of heat to melt zinc would be Q1, which is this, plus Q2, which is this. Q1 plus Q2, that makes it 13540 calories. Yes or no? Right? Fairly simple problem. Let me look at another problem. For you. So then we have three liquids, A, B, and C. There are three liquids, A, B, and C. Having equal masses, masses are M, say, having equal masses M, and temperatures TA is 14 degrees centigrade, TB is 24 degrees centigrade, and TC is 40 degrees centigrade, right? These are their temperatures. Now, what's given is when A and B are mixed together, the final common temperature becomes 20 degrees centigrade. So when A and B are mixed together, their final common temperature is 20. That means A gains heat, B loses heat. A gains heat because the temperature of A goes from 14 degrees centigrade to 20 degrees centigrade, whereas B loses heat because the temperature of B goes from 24 degrees to 20 degrees. So what's the heat gained by A? Mass of A into specific heat of A into temperature increase, 20 minus 14, 6. What is the heat lost by B? Mass into specific heat of B into loss of temperature, decrease of temperature, which is 24 minus 20, which is this. So that gives me like 3SA is 2SB is, say, X. So M and M will get cancelled, and I get a relationship between SA and SB, and I get 3 times SA is 2 times SB is X. Yes or no? So SA is like X by 3, and SB is like X by 2, right? So I want to write specific heats in terms of X. Now, next, B and C are mixed together. What happens? When B and C, see, B is at a temperature of 24 degrees centigrade and C is at a temperature of 40 degrees. So then, eventually when B and C are mixed together, then B is going to gain heat and C is going to lose heat. Why? Because C is hotter than B. So their final common temperature would lie between 24 to 40, and that's given to be 34 degrees centigrade. Final common temperature. So then, what if their final common temperature is 34 degree, B gains heat. How much of heat is gained by B? Mass, specific heat of B into 34 minus 24, change in temperature, right? And that must be the heat lost by C. Heat lost by C is what? Mass of C into specific heat of C into its initial temperature minus final temperature. It has lost heat. So initial temperature is higher than final temperature. And that gives me like a 10 SB is 6 SC or 5 SB is 3 SC. So SC then I can obtain in terms of X. SC is 5 by 3 SB, where SB is X by 2. So SC also becomes like a 5X by 6. So I know SA, SB and SC all in terms of a common factor X, right? The problem says when the three are mixed together, what is the final common temperature? What is the final common temperature? Let us say that the final common temperature is T. T is the final common temperature. Then algebraic sum of heat gained by A plus heat gained by B plus heat gained by C must be 0. Let me assume all of them gain heat. Right? Let me assume all of them gain heat. Then you know, some of them would be positive, some of them would be negative, but their algebraic sum must add up to 0. Heat gained by A plus heat gained by B plus heat gained by C must add up to 0. What's the heat gained by A? Heat gained by A is mass into specific heat of A into T minus 14. 14 is its initial temperature. What's the heat gained by B? Mass into specific heat into increase of temperature T minus 40. And that is C. And what is heat gained by B? Mass into specific heat into change of temperature T minus 24. And they must algebraically add up to 0 because some must be positive here, some must be negative. Eventually, when you solve for T, T turns out to be 30 degrees centigrade. T turns out to be 30 degrees centigrade. That's the final common temperature when the three are all put in a common pool. Thank you so much. But I'll come back with more problems on calorimetry just to get you hands-on with the same stuff. Bye. Have fun.